Hi everyone, it's Sandra. This is my now indoor worm bin I call Peekaboo. Peekaboo went through a harvest not too long ago, but very recently just devoured half of a really rotten onion. I'll put an insert in here of what the worms looked like when they tucked into the onion. It was in this end. And I'm seeing that there is no trace left of that onion, lovely rich vermicompost in its place. And although I noted some smell of onion when the onion was in the throes of decomposing about 2 weeks in, there's no trace of any onion smell now. What I am seeing here is quite a few roly-polies running around, and I think I actually might do something about that. Normally, I just let these guys do their thing, but one time I remember pulling out about 24 roly-polies out of one of my indoor bins and moving them to an outdoor bin. We know these are beneficial isopods, or at least that's what everyone says, so I'm actually going to dig into the research and let you know what I find as I feed and fluff the rest of this worm bin. What I found is that the isopods that cohabitate with your worms are important. They dig burrows and tunnels through the vermicompost. They actually travel along the same channels that the worms create as well, depositing their feces alongside the worm castings. They also interact with the microbial population of the worm bin, which you know is the primary decomposers of any organic material. Depending on where you live, you probably have different isopods in your worm bins and in different numbers than I find here on Vancouver Island. But I think we can all agree that there are going to be some in common with all of us. The research I looked at, of course, studied this in laboratory conditions, so your results may vary. I always have to put that qualifier on there. Depending on your geographic location, if you keep your worms out in outdoor bins or even in indoor bins, but feeding them different things, etc., than the researchers did. I'll put links to the studies I referenced in the description in case you want to go digging into the research as well. The first study I looked at examined 3 different families of isopods. In the first group, they put together all the different forms of mites. Mites are those tiniest of isopods that you might find crawling up your forearm when you're rummaging in your worm bin. They're really tiny, the size of a poppy seed, and they are related to spiders. The second category that this research looked at are the springtails. Springtails are clear or cream colored or white colored. They move slowly unless disturbed, and then they actually can jump. The third and final category of isopods were millipedes and ants. Interestingly, this study did not look at roly-polies, but it was so compelling, the results in terms of isopod diversity and the results in terms of vermicompost quality, I really thought I should include this study. The second research study I looked at does include roly-polies, and I'll mention it next. The first 2 groups, the mites and the springtails, with increasing numbers, you will find a significant increase in the amount of nitrogen, potassium, phosphorus, calcium, and magnesium in the vermicompost. So the more of these isopods you have in your bin, the higher your vermicompost quality will be in terms of those elements and minerals. Conversely, the more millipedes and ants you have in your bin, you will find your vermicompost will have significantly less nitrogen, phosphorus, potassium, calcium, and magnesium. Now, I've never liked ants in my bin, and thankfully I've never had a big problem, but I've always just tolerated millipedes. Now I find out that they might not be so great for the resulting vermicompost quality. Remember, quality of vermicompost is not just in the NPK and calcium and magnesium values, but it's in the microbial richness. So you always have to bear that in mind. When I was doing this check-in, I changed my mind about pulling the roly-polies. and I'll add them back to the feeding zone with all these chunky bits. I knew I had to look into the research of Armadillium vulgare, what a great name, to find out what they do for vermicompost. It turns out it's all about size. Size matters when it comes to isopods. Mites and springtails are considerably smaller than the adult roly-polies. Mites and springtails have really small poops. The feces that they deposit on all those channels and tubes in a worm bin, those little piles of feces attract microbes, and the microbes get busy on extracting those minerals out of the vermicompost organic material. That's called mineralization, so those isopods contribute to increasing the nitrogen, potassium, phosphorus, calcium, and magnesium of the vermicompost. Now, if you'll remember from my worm science video that I did on the carbon to nitrogen ratio, you'll remember that carbon naturally decreases as vermicompost approaches being completed. But you don't want the carbon to disappear all at once. That's where the roly-polies come in. Roly-polies have big poops, so those big clumps of poop aggregate around carbon, preserving it in the bin, so it is released more slowly. It's all about balance, and Mother Nature does a great job. Bentley, the compost guide, Christie, was the first person I heard mention that isopods are necessary to chew up the chunkier bits of material that we put in our worm bins. Without isopods, it's going to take a bin much longer to process, especially dense materials. Here on Vancouver Island, I have gigantic leaves. In fact, the maple tree in my backyard is called a big leaf maple. My sister used to joke that you need one wheelbarrow for every maple leaf. They are absolutely massive, and their leaf stems are sometimes a pencil width. So you can see that I need isopods in my bins if I'm going to feed them my beautiful maple leaves. So the isopods chow down on that softened organic matter, breaking it into smaller and smaller pieces. And then the worms come along and they ingest that softened, broken down into smaller pieces matter that has been populated with microbes. And the worms further decompose it by chowing down on it and chewing it up in their gizzard. I use the word chewing. I know worms don't have teeth, but the gizzard does break the material down into even smaller pieces. Before I did this video, I thought the breaking into smaller pieces was the extent of the isopod involvement, but of course with research I found that it goes much deeper than that. It turns out isopod poop affects microbes and the carbon cycle differently. And then there's the role that chitin plays. One thing that isopods bring to your worm bin is chitin. Chitin forms the exoskeleton of these insects, and when these insects die, the chitin is absorbed into the bin. Worms have a gene that will break this material down. They produce an enzyme called chitinase, and therefore they are important in degrading chitin and recycling it into the environment. Vermicompost they produce has massive amounts of chitinase excreted by the worms, and this chitinase helps plants bolster their defenses against attacks by insects. I'll show a little tape here of the exoskeleton of a roly-poly that I found in my bin the other day. Of course, I just tossed it right back in so the microbes could attack it and the worms could break it down through their enzymatic activity. So thanks for following along as I dive into the research on isopods in worm bins and give Peekaboo a much needed feeding and fluffing. I hope the next time you find an isopod in your bin, you will smile knowing that it's there for a reason and they all have an important role to play. Thank you so much for watching. Bye for now.